Let's get started here. All right, so just so that we're all on the same page, everybody knows that you're turning in the last IB problem set by Monday morning, right? Everyone's got that?
Yep.
Awesome. Now, questions on that IB set as of right now? Has anybody done any of those problems? No one? Okay, if you did 9 and 10, that's good. Okay. All right, well, so let's talk about infinite sequences in series. Okay, geometric ones. Now, first of all, this isn't going to take the whole block. It's pretty short. It's only one formula and it's like one concept. But the rest of the block, we're going to kind of like review all the stuff that we did. Or I'll answer questions from everybody. Okay, so let's first talk about infinity. All right. First of all, one thing that you should never, ever, 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 ever do is write this. That never happens. You should never, ever, ever put an equal sign and an infinity sign next to one another. And the reason why is because you can't ever equal infinity. Okay? So let's think about that for a moment. You know, if I were to uh, if this were the case, then realistically you could do something like this. You see what I mean? You can't do that. You can't have an equals next to an infinity. They don't work. Um, and there are a lot of reasons why, but ultimately the long and short of it is that an infinity is a destination. It is not a location. You can't be there. You can't get there. All you can do is go towards it. So let's just talk about some vocabulary really quickly. We have convergence and we have diverge. And so to converge means that eventually so if you are getting arbitrarily close to a value, okay, so first of all, everyone took algebra 2. We are all familiar with the concept of a asymptote, right? So when you're talking about an asymptote, you know, you got something that kind of roughly basically looks like that. And, you know, as we keep going further and further off to the right or to the left, whatever it is, then what's happening is that you're getting closer and closer and closer to 5 or whatever the heck it is. The idea here is that if something converges, that means it approaches a constant where a is an element of the real numbers. Okay. Things that diverge do not. So, for example, things that go off to infinity, things that go to negative infinity, things that don't ever make up their mind. Okay, if they're just bouncing back and forth, and a classic example of something like, first of all, we've all seen this. Okay, we've dealt with end behavior before, right? Where as x approaches infinity, y approaches negative infinity. That's divergence. As x approaches positive infinity, y approaches positive infinity. That's divergence. This is less clear. So I'm just going to take a quick second, and we're going to take a look at that. And later on next year, we're going to spend a little bit more time on this sequence, but let's talk about this one. So this sequence, when a is 1, when n is 1, we've got -1, and then I've got +1. When it's 2 and it's squared, right? And then -1, and then +1, and then -1. Okay. As I go farther and farther and farther down the road, I'm not approaching a single specific value. I'm approaching 2 values at the same time. And this, since it doesn't go to 1 and only 1 specific value, this does not converge, this diverges. Now, the sequence diverges. Now, let's look at its series if we were to try to add this one up. So let me ask you this one. If I were to do this, What do you think it would add up to? Oh, sorry, it starts off with 1, so we should do that. What do you think it adds up to? Take a guess.
0.
That's a good guess. Anybody have anything else?
Infinity.
It's another guess. In fact,
-1.
it could add up to 1. Actually, it adds up to both 0 and 1. It adds up to both values. And you're like, why? How can that happen? Here, I'll write it twice. Crazy stuff happens when you start fooling around with infinities, guys. So somebody said right off the bat that, hey, look, they're all 0, right? So each of these, -1 and 1, depending upon how I group it, these all become 0s, except for the first guy. He survives. So this guy equals up to 0. This guy equals up to 1. It doesn't equal up to anything. So this is an example of a series that diverges because it doesn't go to one and only one specific value. Okay. All right. So I need you to know the terms converge and diverge because I'm going to use them all the time. Now, so let's talk about an infinite arithmetic series. And let's see if what this would even look like. So let's start with something small. And let's say we're going to add a term. And the term that we're going to add, d, is 1/2. So now I've got 3 halves. And I add another half, and I've got 2, 5 halves, and 3, and 7 halves. And the problem is that they're always getting bigger. And you see, if I add up all of these boxes, is it going to converge or diverge? No guesses?
Is going to converge.
Okay, well, what would this converge to? Well, let's say that it does, okay? Some number, L, down the road, right? And at some point, there's a last term. And it's bigger than the term before it. So if I were to add one more term, because remember, it's infinite, now my limit is going to get bigger. So the problem here is that with an arithmetic series, you're always adding bigger and bigger terms. Each term gets bigger. So we can go small, and then they get big. And if you're adding big things, then you're not going to be converging to a single value. You see how that kind of works? It's like if you're always adding something bigger, then your number is always getting bigger. And you're never really getting tinier and tinier and tinier. Okay, so let's think about that idea of an asymptote. If I've got, in order for something to converge, as time goes by, I have to get closer and closer to something. But with an arithmetic series, I've got a linear function, and that guy goes off to infinity. So an arithmetic series diverges, always, if it's infinite. Now, if it's finite and it stops after 20 terms, then yeah, it stops. You're done. Game is over. But adding up an infinite number of them becomes a problem because you've got a function that basically goes like this. Okay. So if an arithmetic doesn't work, let's take a look at a geometric. All right. So we've only got 3 choices here. We've got a term, G1, and now let's look at G2. So with a geometric series, we've only got 3 choices. We can either get bigger, stay the same size, or get smaller. So if something were getting bigger, what would R have to be in order for G2 to be bigger than G1?
Has to be a number bigger than 1.
Right. R would have to be greater than 1. So let's think about that for a moment. If G2 is getting bigger, and we're adding them up, right? G1 plus G2 plus G3, and so on, and every one of them is getting larger, do you think that we're going to eventually get to a single value?
No.
Same reason, right? Okay. So that becomes a problem. So R cannot be bigger than 1. Let's think the third scenario, staying the same size. G1 is equal to G2. What would R be in that case?
Has to equal 1.
Right. So now let's think about that. G1 plus G2 plus G3. And, this is 5 plus 5 plus 5 plus 5. Am I going to converge or diverge?
Diverge.
Yes, because you're always you're getting larger and you're always adding 5. So no matter what you think you might be converging to, you can add one more term and now you're bigger than that, right? Okay. So we've only got 3 choices now, and the last one is G1 is greater than G2. And what would this case be? What is R?
R is less than 1.
Okay. And we don't want it to be 0, right? Because that would kind of be boring, wouldn't it? I mean, but that's okay. We'll talk about 0 in a minute. So let's think about this for a second. So I'm multiplying by a number smaller than 1. And we've done this in the calculator everyone has been bored in your math class and has done something like this, And you do, like, I started with 85, just out of, whatever, divided it by 7, and I just do this. Keep hitting enter, right? And you do this and you're bored out of your mind, and eventually what's it doing? Where's it going?
0.
Yeah, it's eventually creeping to 0. Thank you, Mr. Student Aid. So, so if I think about this for a moment and I say G to the N is equal to G1 R to the N, and if N gets bigger and bigger and bigger and bigger, and that means that I've got something like this. G1 is being divided by some number because the r is going to be smaller than 1. And now what's happening is my denominator is exploding. I'm dividing by a lot of stuff, right? Let's take an example. Maybe it's best to see that. Let's take 85 is G1, and R is 1/7, just like I did in the calculator a minute ago. Well, if I go to my 100th term, just for giggles, now 7 to the 99th power is big. It's really big. It's huge. Now, if I'm dividing by a gigantic number, what happens to the overall number?
It's super small.
Yeah, the bigger your denominator gets, the smaller and smaller you are, right? I mean, which is bigger, 85 over 10 or 85 over, I mean, that's big. That's only 8.5. That thing is microscopic, okay? So the bigger your denominator, the smaller your number. So here's a classic kind of example. I take a high bounce ball and I drop it off of the tabletop onto a hard floor. And when it bounces back 80% of where it was. Now, in real life, we have friction, air resistance, and those create heat, which is another form of energy. So eventually what will happen is, in real life, as we all know, the ball will eventually come to rest. But in an ideal situation where we had perfect elastic collisions, then this thing would continue to bounce, albeit very, very small, down to the atomic level forever. Okay? But again, that's math versus reality. So in a situation like this, I am eventually going to come down to 0. And there's your asymptote. Now, let's think about it mathematically. So here we are, and r is small. Now, as n gets, let's, for example, say s of 10. So if r is small, and I'm, and I multiply it by itself 10 times, even if it's, like say 0.99, if I do that 10 times, I'm still small. Now, if I were to do that 1,000 times, now I'm really small. And I've only gone to 1,000. Now, if I eventually go out to, say, 1,000,000, what is this thing going to become, basically? What does it eventually go to?
Almost 0.
Yeah. Now, if it's really, really big, it's almost zero. But if it is infinite, an infinite distance away, what does it become? As we get closer to infinity, it goes towards zero. And when we eventually get to infinity, how big is it?
Zero.
Right. And since that goes to zero, the sum of an infinite number of infinite geometric series, this just goes to zero, so I have one, and then my G1 pops up top. So this is your last formula for that grid, and this is the infinite sum of a geometric series. Now, there's a condition on this that we said. We said that R had to be less than 1. However, there's one small caveat to that. What about this? Let's say we have, let's start off with 10, and then it's 5, and then -5/2, and then, oh wait, I'll start off with -10, and then +5/4, and -5/8. First of all, what's my R?
-1/2.
So if we were to look at this as a graph, I'm starting off at -10, and then I'm going to +5, and then -5/2, then +5/4, then -5/8. Is it impossible? First of all, is it going to converge or diverge?
Converge?
Yeah, look, you can see it. It's getting closer to zero, isn't it? It's basically still going to zero. Now, if they were all positive, it would look a little different, granted. If they were all positive, then it would look like this. And that converges, and this converges. Just because it's oscillating, eventually it's going to get as close to zero as you could get. So my point here is that we can have a geometric series converge, an infinite geometric converge, as long as my ratio is between 1 and -1. And written another way, which might be useful if you were trying to do some problem on your homework set, you could write it like this. Don't forget that form, because that and this mean the same thing. So a question might look like, let's do, so the question might be, so for something like this, so the first question you have to ask yourself is, what is the R? What is the thing that is being multiplied on each step?
5x plus 4 over 3.
Yes, so that's my R. So I need the absolute value of 5x plus 4 all over 3 to be less than 1. So in order to do that, most people don't do algebra with compound statements, so you're going to learn it now if you don't already know it. So your job is to get x alone, so I'm going to multiply everybody by 3. Now I'm going to subtract 4 from everyone. And now I divide everybody by 5. So as long as x is between these values, this thing will converge. Okay. Now, what if I told you that this thing converges to 3/4? What's your value of x? So if it converges to 3/4, that means that's my sum of my infinite series. So 3/4 is equal to G1 1 minus R, because that's your formula. Now G1 and R are the same thing, because that's my G1 and it's also the same thing as R. So now let's simplify this and see if we can get it down to something that'll work. So I'm going to multiply the top and the bottom by 3 to get rid of my denominators. Okay, and see what happens there. When I multiply the 3 to this, it cancels the denominator. Multiply the 3 to that gives me a negative, gives me a 3. Watch out, the negative sign is for the entire term, so we have to consider the distribution. Distributing that and combining it gives me -1 minus 5x, and that is equal to 3/4. And now it's just a matter of algebra to cross multiply and solve. So 4 times 5x plus 4 is equal to 3 times -1 minus 5x. 20x plus 16 is equal to -3 minus 15x. So 35x is equal to 13. X is equal to 13/35. And just to make sure that that really flies, which it should, we said that this thing had to be between what and what? What's the other value? Well, again, I'm arbitrarily made up this problem. That's why this number isn't within our radius, but that's how you would solve it.
Wait, shouldn't one of them be negative, right?
Which one?
Because if you're moving it over, it'd be 35x is equal to negative 19.
Oh, negative 9. Yeah, I was like, wait a minute, because I was supposed to be getting a negative number. Thank you. It's like, you see, this is what happens, guys. You know, I can do all this, but I just can't add up two numbers. You know? I mean, like, yeah, this is me, right? Welcome to my life. All right, that's why I don't work for NASA, you know? It's like, I could build the rocket and then probably light the wrong end. You know? I mean, and negative 19 over 35 is approximately negative 0.371, which is between negative 1/5, which is negative 0.2, and negative 7/5, which is negative 1.6. So it does work. Okay. All right. So anyway, that's the geometric one. The infinite geometric series. So here's the deal. We have time. What I would like to do is I would like to open the floor to questions or topics that, or homework problems, or anything that you've seen that you're like, dude, what are you doing? You know, now is your open floor.
On the homework that was due today,
Yes.
problem number 3, I didn't like fully understand.
Can you read it to me? Because I don't have the file open. Let me see if I can, maybe I can find the file. Give me a second. Do you have that question? Because I'm not finding it really. Oh wait, geometric sequences homework was it was a picture.
Yeah.
Okay, hold on. I've got that. I've got that one done. Oh, I have the answer key written. So for number 3, how many terms are followed? Okay, a lot of people had questions on that one. You weren't alone. A couple people came into office hours and asked about that one. All right, so question. So which one you wanted, B or just 3?
Just 3.
Okay, so what's going on here is you're trying to get to and let's do these 5 1 1/5. So G1 is equal to 5, R is equal to 1/5, and what we're trying to do is we're trying to get the yeah, you know, it's not the sum, it's the term. So you're looking for G sub n to be smaller than 10 to the negative 9th. Now G sub n is G1 R to the n minus 1. Now, we know what G is, we know what R is, we don't know what N is. So what we do there is we plug in what we know, 5 1/5 N minus 1. And what we're the way to get around this to make sure that you're not messing, because in a minute we're going to be taking logs, and in order to not screw up the flipping of the symbol here, it's oftentimes easier to just lie, call it equal, and then check your answer. So first we get the 5 out of there, the full size 5, not the reciprocal. And now we have 1/5 to the n minus 1 equals 10 to the negative 9th divided by 5. And now we need to get this exponent out of there. And in order to get an exponent out, we use a natural log. So we take the natural log of both sides. And when you take the natural log of an exponential, the exponent comes down as a coefficient. Now, this is just a calculator job. I mean, that's just a number in the calculator, right? That's just a constant. So there's nothing exciting there. And this is just a constant. So we divide it out. Big, ugly calculator job, but we don't care. And then you get rid of the 1 by adding 1 to both sides. And that's your answer. That's the, and judging from the massive amount of consternation that people had over logs, I've changed the curriculum slightly, and we're going to be doing logs next unit because everybody has issues with logs. Yeah. How about this? If you have issues with logarithms, please raise your hand. The little blue hand, please. I love it. Faris, stop lying. Raise your hand. Okay. All right, you can put your hands down. All right, that's what we're going to be doing next unit. Now, part B on number 3 was particularly thorny because you wound up with this. You had an R that was negative. And so you had 4, -2, 1. And so you had G1 is equal to 4, R was equal to -1/2. Now, some silly things happen here in a moment, and we have to take them into consideration. So we have G to the n, G to the n is less than 10 to the negative 9th. So G1 R to the n minus 1. And now 4 -1/2 n minus 1 less than 10 to the negative 9th. And then -1/2 n minus 1, 10 to the negative 9 all over 4. Now, here's a problem. Oh, I forgot a step in the last problem. I have to check my answer to see what the answer is, but we'll do that in a second. We'll do it with this one. Now, the problem is that if I tried to take a logarithm right now, I can't, because I can't take a log of a negative. So what we have to realize is what we're dealing with here. We are dealing with something that oscillates like that. Okay, it's that alternating series there. Now, all I care about is finding the value somewhere down here that's below 10 to the negative 9. So the distance from 0 is really all that I care about. It doesn't matter to me if that distance is a positive distance or a negative distance. It's still a distance. So this series, 4, 2, 1, -1/2, and so on, is going to have the same behavior as that, where everyone is positive. So that means the answer that you're looking for, just drop it. Drop the negative. And by dropping the negative, now we can take the logarithm. And now you have is it minus plus 1? Okay, now, and this is where we've got to care a little bit. So let's actually compute that. And I get 32.89. Now, the question is, do we round up or do we round down? And if we look at the easy way to check it is to plug in 32 and plug in 33 and see which one of them actually gets you smaller than 10 to the negative 9th. Okay, so if my original guy was this fella, no, wait, that was the other problem. The original problem was 4 negative 1/2 n minus 1. Let's just take 32 and 33, plug it in, and see what you get. So when n is 32, I get negative 1.86 times 10 to the negative 9th. And when n is 33, I get 9.31 times 10 to the negative 10th. And so which one do I want?
33.
Because this is not less than 10 to the negative 9th to 0. Okay? So I've got 2 hands raised. Min, I think your hand was raised first. Or is that a hand raised from before? Maybe she's taking a nap. Karam.
Yeah, so how did you, I'm looking like at your work, how did you get the negative 1/2 into a positive 1/2?
You lie. Seriously, that's the answer. Yeah, you lie. Because what, well, first of all, if you don't want to lie, you don't have to. You can solve it without it. But it's much harder. Now, but let's think about it this way. An alternating series versus a non-alternating series are only different from each other because this guy has a negative 1 to the power that flips it back and forth between positive and negative, right? Whereas this guy doesn't have that flipper on it. However, the absolute value of an alternating series function is this, right?
Yeah.
So what I can do is I can say, all right, if all I'm interested in is getting close to 0, then that means I don't care if it's above or below the axis. And besides, when you take the natural log of a number, you always take the absolute value of it. you can't, because the natural log of or the log of any base, the log of a negative number is non-real. Those are complex numbers, and we're not fooling with those right now. So when I take, if I were to take the natural log of r, now what's happening is that I'm basically dropping the negative sign as a result of it. So yeah, you can kill it because of the absolute value bars. Now, let's just say you didn't feel comfortable doing that. Okay, fine. And then that means we're at this situation. We're sitting here. Now, here's what we do. We lie. Again, there's a lot of lying in math. Or at least a lot of lying in my class. And what we do is we graph it. Let's see what happens. That's actually the function itself. Or is that, hold on. Yeah, that's actually my second function, which you can't even see.
Yeah, that's what I got when I graphed it.
Right.
Only-
Because, first of all, because let's think about what happens when we're dealing with, say, x equals 1/2. How do you graph it? Because when x equals 1/2, or any rational function greater than, sorry, any non-natural number greater than 1, you're going to wind up with a fractional exponent to a negative base. And now you're taking, like, you know, the fourth root of an imaginary number. You see what I mean? And that's why you don't have real values in it. However, you can use a table. And use your table settings to say 0 delta table is 1, and this way it's always using whole numbers. And you're going to have to come down here all the way down to the very bottom to find the point where it's smaller than 10 to the negative 10th. And there it is. And it's actually kind of, you know, there it is at the, but you see it's right here at the 33rd term, because 2 to the negative 10th versus 3 to the negative 10th. Right? So yeah, you can do it, but you'd have to use a table to do it. You can't graph it.
Okay. Thank you.
No problem. But you're perfectly allowed to drop negative signs and absolute values for logarithms. Did I post that homework? I'm sorry, did I post the answer key to that?
I don't think so.
Okay, that means I'm going to do it right now because I've got it.
So then how did you know to use a natural log instead of just log?
You could have used any log. Any log will do it. They'll all give you the same answer. Any log at all. Although I like natural log because natural log is easy. But you could have used log base 68 and it would have worked. Okay, so I did post the IB problem set number 1, arithmetic sequences in series. I posted that under announcements. Where the heck is the other guy? Here's the geometric. Okay, so let's do this. Since I've got everybody here, we can all take a look. If anybody wants to pull, here's the way we do it, by the way. It's called parliamentary procedure. And so you've probably seen this if you've ever watched C-SPAN or if you've ever been in a really, really big meeting. I am the chair of this committee, okay? And what we will do is I'm going to ask this committee, this board, a question. Now, if nobody objects, I'm just going to move right through this. So if somebody wants to take a look at 2A, they have to say, I object, and then I will stop, and we will go over 2A. But if nobody has a question on this entire page, then we're just going to move on. So, looking at your homework, is there objection to moving on past this page?
Yeah, for 2C,
Yeah.
I got n equals 12, and because I had n minus 1 equals 11, and then I took the minus 1, I had to add it.
Yes, but then you would have a 1/2 in front.
Wait, I did mine differently, I think.
If your R is 1/2, right?
Yeah.
And your G1 is 1/2,
Yeah.
then you would have written it like this, right?
Yeah.
And since this is to the first, and they are the same base, you can add your exponents and just get that.
Oh, because I think what I did is I divided the 1/2 to the other side, the one without the n minus 1.
Oh, this one?
Yeah, so I divided to the other side.
This is to the 10th. So if you took that and divided it to the other side, you would have gotten 1/2 to the 9th.
But wouldn't I need?
I know what you did. I know what you did. You did this.
Yeah, that's what I did, and then okay, and then I made it 2004, 2008.
So what you did was in order for, first of all, this is incorrect. And the reason why is because in order to get rid of this 1/2, you're multiplying both sides by 2. What you did was divide both sides by 2. You multiplied by 2 on this side and divided on that side.
Oh, okay. I see what I did.
Yeah, that's what'll do it.
Okay, thank you.
Any other objections to moving past this page? Min, hold on, let me answer your question in the chat. For the geometric sum equation, do we always use the simplified version? What do you mean simplified version? One of them is for infinite and one of them is for finite. They're for different things. They're not the same. Oh. I'm not going to kill you and eat you. You know, I'm not, well, yeah, I'm not going to kill you and eat you on that one. However, you might find that one form is nicer to look at than the other. But no, I'm not going to kill you and eat you on that one. There are more important things to worry about. Okay, hearing no objection, I'm going to move past this page. Seeing no hands, hearing no objections, we will move forward. Is there objection to moving forward? Crickets. Okay, hearing no objections, we will move forward. I actually got everything else on this page, so this is a big page. Questions on this one? Number 7, yes. Okay. Anybody else have any questions on this page before I move into doing number 7? I have a request for number 7. Okay. Yeah, of course. Happy to. Number 7. Okay. So in number 7, I'm not looking at the assignment. Let me see the page. The difference between the fourth and the third term of a geometric sequence. So G4 minus G3 is 75 over 8 G1. So, well, the first thing is that when I saw this question, it didn't say which way you were subtracting. It just said the difference between them. So we've got two scenarios, this one and this one. And there was a clue in the question where it said, find all possible values of the common ratio. And that to me says we're either going to get a quadratic or we're going to have another situation where somewhere along the road, it's going to lead me to more than one answer. So that's why it made me say, okay, you know what? I got to play with both of them. So anyway, let's just work with this. So G4 and G3, we're going to rewrite them in terms of G1. And that's G1 r to the third, G1 r squared, 75 over 8 G1. And since all three terms contain a G1, I can eliminate them. R cubed minus r squared is 75 over 8. Now, you're not going to try and solve this thing algebraically. It's easiest to just graph it and find the points of intersection. And when you do that, it comes up to 2.5, or r is equal to 5/2. And if you graph that, it looks like, you know, it's basically got this kind of a shape. Like that, something like that. And you find the point of intersection. And this guy over here looks exactly the same, except it's flipped around, and you wind up with r squared minus r cubed is equal to 75 over 8. And when you do that and you graph that guy, he comes out to be negative 1.8225. And when you graph it, it basically looks something like that, because this guy's been flipped upside down. Everyone cool on number 7, or a little bit more, or what do you need? Back to the last page. Questions, issues, moans, whines, complaints. I've taken pictures of these and I've made a PDF file. I just was waiting until class to post it on the announcements, but I want all of my answer keys posted for you guys to look at before the quiz. Any other questions about this? Any other questions about any other assignment? Any other questions on winning lottery numbers?
What do you choose? Random
Problem
or would you pick it?
They were all irrational numbers. What can you do?
You're not wrong.
Well, everyone said I was crazy. So yeah, you know, it's really hard to bubble in the square root of 2 on a lotto form. No, I've never done that particular number. Although I've often thought about doing my favorite 6-digit number. There are some really fun numbers out there, and we've only got 5 minutes left of class, so I'm just going to show you. I'll show you this number. This is crazy. That number. Believe it or not, this is called, it's named after a demon. Oh gosh, it just slipped right out of my head. This is a prime number, and it's 13 zeros, 666, 13 zeros. It's a palindromic prime, and palindromic primes are prime numbers that are prime written in both directions. They themselves are palindromes. Belfiger's prime, that's what it is. Yeah, he's a demon in the it's like one of the layers of hell or something like that. Yeah. And anyway, it's kind of a cool number. He's one of the princes of hell who helps people make discoveries. Yeah. Anyway, fun numbers. Then there are also vampiric numbers. They're out there, vampire numbers. And there are lots of crazy numbers out there, and that's for another day. But anyway, does anyone have any questions at all before we leave for the weekend?
Just to put this in my agenda calendar, what day is the quiz?
Next class, which is Tuesday.
Got it.
Okay, so to do this, ladies and gentlemen, what we're going to, the process is going to be, I will post the quiz at the beginning of class on the Canvas page. You don't have to print it, but you have to download it and look at it, right? Obviously. And because I'm not going to give you like lots of room to work in. It's like, it's going to be like, you know, here's number 1, blah, blah, blah. Here's number 2, blah, blah, blah. Here's number 3, blah, blah, blah. And so you're not going to have room to put your answers. But you are going to take pictures of your work, and then you're going to email me the pictures. The things that I'm looking for are, this is number 1, blah, 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 blah. X equals 2. You know, I don't want to have, and you know, draw a line so that I know that 1 ended and 2 started. Okay. Box or circle your answers so that, just make it, guys, think about it this way. Look, I got 21 kids in this class. and everybody's going to send me like 4 or 5 pages. Can you imagine? Like, let's be realistic. I got 80 to 120 pieces of 80 to 120 images that I have to look at. So really, actually, you know what I'm going to do so that no one gets lost? I want everyone before the test to write their name at the top of each paper. Okay? Now, because if I lose your picture and I find it later, I want to be able to say, oh, that's John Doe's. Okay. So there's a question in the chat was, okay, so like looking at the, so if you saw my arithmetic answer packet, wherever the heck that is, oops. The answers for my arithmetic sequences assignment, and I'm just going to load that up right now. Okay, so I'm going to share my screen with you so you guys can see what I'm talking about in terms of how do you get points. Okay, so for example, this is everyone looking at my picture of my work? Emma, you're the only one whose face I can see. Are you looking at a picture of my work?
Yep.
Okay. Notice the M1s, the A1s. So let's just say you didn't get that far. You didn't find the final answer of 10,300, but you did get all the way to figuring out that A1 was equal to 2D. So if you can figure out that much, you've already gotten 3 points. So it's not about the final answer. Okay, I've been harping on this for a while, guys. It's not about the answer. It's about the process. Okay. Now, everybody's going to do their work on blank paper. If anybody turns in lined paper, I am not going to grade it. Blank printer paper. Okay. Make sure it's relatively clean. Do it in pencil. All right. For the quiz, is there a time limit? Yeah, the block. At the end of the block, we're done. And how many questions? I haven't decided, but I will tell you that there will probably be something on the order of 6 to 8, maybe 10, but no more than 10. Because quite honestly, I don't want you spending all of your time busting your butt on one problem. You are taking the test on Zoom. Okay, so you will come to class, and once I have everyone here, then I will send the test out. You are on your honor, of course. I mean, there's not very much, because apparently there's only one person who actually shows their face every day, maybe 2, but you know, you're on your honor. There's not a heck of a lot I can do about that. But I'll tell you, if you're cheating, then you're hurting yourself, because you're going to be with me for 2 years. And if you're cheating on the very first test, let's find you a seat in a different class. Other questions? All right, it's 2:43. Everyone have a fantastic weekend. If you have any questions, please email me. I will be happy to work with you on Monday if you need it. Wait, didn't I say there was a review session? I did. Okay, yeah, one more thing. I thought I said that, didn't I? Or was that the HL1, HL2s? Okay, here's what I will do. On Monday, I will have office hours just for this class, no one else. from 12 to 1. And you just use my office hours link. Okay. And if you have any questions, I'm open, and no one will come. And the only people that will be here will be people from your class. So it's not like, you have to wait for a geometry kid to be done or an HL2 kid to do whatever. Okay. Everybody happy?
Mr. Rocco,
Speak to me.
on your announcement, you said that the study session will be at 11 to 12.
Oh, did I? I thought that was for HL1, HL2s. Okay, good. 11 to 12 makes it easier. Beautiful. Thank you. I knew one of them was 11 to 12. I wasn't sure if it was HL1 or HL2. Sorry. So yeah, 11 to 12. Thank you, Bennett. All right. If no one has any more questions, take care. Have a great weekend, and good luck with everything. See you later.
Thank you.
Thank you.
Sure.
Thank you.
Good day.
Thank you. Bye.
See ya.
Mr. Ronco.
Speak to me.
Hey, I shot you an email last night, but I didn't get a response. For number 3, when you were going over the calculator that one day, I was waiting. I'd actually broken my calculator a couple days before, so I was waiting on a new one to come in. So how do you put that into the calculator? Just because I'd worked through 3, I looked up what I was supposed to be getting to see if the answers I were getting were right, and they weren't even close.
Number 3.
Yeah, I can read it out.
A or B?
Let's do A, just because that was the one I tried the most. But I just didn't know how to put it into the calculator, and I looked it up online. I watched like 5 YouTube videos, and none of them. I just kept getting 0 or like 1.
Okay, so we're using the same basic calculator, right?
Yeah, I have a TI-84 Plus.
Yes. Okay. So to put this in the calculator, it's negative natural log 10 to the power of 9 divided by 25 divided by the natural log of 5.
Yeah, I was gonna say, can I just take a screen, or I'll just take a picture of that just so. All right, yeah. So you have to make the natural log negative.
Where?
Like you
just in this problem right here?
Yeah, I was gonna say,
Oh,
yeah,
it's only because I have a negative n, and I'm solving for n, so I move the negative n.
All right, because I just, whenever, like, it's somewhere back here, I got a ton of papers, but whenever I would put it in, it just would not work at all. I kept getting 0, and then I asked Jacob what he put into his calculator, and that didn't work either. So I was just
So can you share your screen so I can see what you did? Because I don't know how that worked.
Hold up, I'll just turn my video on. So I tried to follow the steps you did yesterday, and I think I messed them up. So then I went over. You shouldn't be. I don't think you'll see this, but.
All right. Oh, yeah. Well, turn it so I can see it. Look,
you read that?
You're a little blurry. Pull away a bit.
Trying to get to focus. I can just read it out if you want me to do that.
No, get it closer. Move it to your right. Close. Okay, stop.
That's what they said. That's what he said he put in, and he said it worked for him. So I tried that, and I did not have it work. So.
Well, no. No, that doesn't work.
Yeah, that's why I was confused, because I saw it and I'm like, that doesn't look, because I'm like, how are you replacing the n in that natural log? That's what I was confused about.
No, you do this. First of all, now I'm wondering about Was it 10 to the negative ninth, right?
Yes. They said bring it down underneath, and I was like, that's because that wasn't the way you showed me, and that's why I was confused.
No,
'cause I'm
you
like,
just divide it.
yeah.
It's a number.
hmm
So I've got 5 times 1/5 n minus 1 is equal to 10 to the negative ninth,
hmm
right?
Yeah.
So I just did a little bit of rearranging and made it 25 times 5 to the negative n is 10 to the negative ninth. You don't have to do that, but you can. Even if you didn't, let's just say you didn't simplify it. Let's just say you left it like this.
Mhm.
And now you want to apply the log on both sides.
Yeah.
And this comes down in front.
Yeah, and it brings it over. And then you just divide by the log right on the other side.
Yeah. Because remember, this log is just a crazy decimal constant.
hmm
And then you just add 1 to it. And there's your answer.
Yeah. So then I just plug that into the calculator then?
Yeah, it's a calculator.
So
straight
yeah,
up
because
calculator.
how do I do that though? Because I tried that and it kept giving me 0, and I tried to graph it and it would just keep giving me nothing, or it'd say error. So like, do I just put n equals and then plug that in and then hit enter, or do I have to go into the
Well,
y equals or
no, you don't
the?
have to do that at all.
Uh,
Hold on. Why am I getting a slightly different number than I did before? Nope. Oh, that's why I didn't get it right. All right. So go to your calculator with me and just type it in with me. Natural log,
mhm.
10 to the power of negative 9.
All right.
Now push right to bring it
Yeah.
down, full size, divided by 5.
All
Close
right.
parentheses. Now hit enter. You should get negative 22 and change.
Yeah. 0.33. Yeah. All right.
Okay. Now divide that by the natural log of 1/5.
Oh, you know what I did is I put it all in the same problem. I didn't do like that. So I just set it all in together and then hit enter.
That's okay. You can still do that. It'll still
Mhm.
work.
Well, yeah. Well, I tried that and it didn't work. That's why I was like, I think I just put something in wrong. But all right, yeah, this makes
You
sense.
probably just had calculator finger, man.
Yeah.
Sorry, dude.
All right, and then just add 1. All right. Yeah, that makes sense.
14 and change.
Mm-hmm. All right. Thank you.
No problem, dude.
All right. Have a nice day.
You too. Have a great weekend. Bye-bye.
Peace.